and this will be presented by Dr. Hari Subramani. He is a research scientist at the Ohio State University. His current research interests include high-performance interconnects and protocols, parallel computer architecture, network-based computing, exascale computing, etc. He has published over 70 papers in international journals and conferences related to these research areas. He has been actively involved in various professional activities in academic journals and conferences. He leads the overall MPI+CUDA project, including all the different variations, the MPI+2X also, and MPI+2 GDR. He's a member of IEEE. So today in this talk, he will be providing talk to visualize and analyze your network activities using OSU INAM, which is the InfiniBand networking and monitoring tool.
Okay.
So
thanks, Dr. Manda. Hi guys, I hope you can see my screen. So this is going to be a short tutorial on how you can visualize and analyze the OSU InfiniBand network analysis and monitoring tool. So this tool is in its like 5th release right now. So this project has been running for about like 5 years. So I just want to give a quick overview of what INAM can do and what sort of features it has and how you can enable them. And I'll also try to show a quick demo. So there'll be a more detailed demo of how INAM performs at the OSC system by Karen and Hee-Chang later on. So that'll be much more in-depth. So this is going to give a high-level view of what INAM is, what features it has, and things like that. So this is a brief outline of how the talk is going to proceed. Now, if you take a look at it, what is the problem with current day profiling tools? There are several profiling tools meant for different kind of users. You have some profiling tools for HPC system administrators, you have some profiling tools for users, some profiling tools for MPI developers, application developers, so on and so forth. But the major problem with all of these profiling tools is that they only focus on one or maybe two layers of the stack. There is no tool available right now which can give you a holistic view of the entire stack, starting from the communication and I/O fabric, the MPI library, how that interacts with the job scheduler, and how all of this interacts with the HPC application. So this is what INAM is trying to solve exactly. So in order to, INAM enables people to understand the interaction between applications, MPI libraries, and the communication fabric, so that you can find, for instance, root causes of performance degradation, identify which among these different layers is the possible cause, and also understand the interplay between the internal MPI protocols being used and how that impacts your communication network. So for instance, if you look at it, an MPI library can have dozens of collective algorithms. The application may not be aware of this. From the application's perspective, I'm calling MPI all-to-all or MPI vcast. But internally, MPI might be calling one of 20 different algorithms for broadcast, or maybe like 6 different algorithms for all-to-all. Now, how does this particular algorithm interact with the communication substrate? Is it causing more contention? Is it causing more congestion? Is it leading to suboptimal utilization of bandwidth? So these kind of questions are kind of very hard to answer right now, and this is what INAM is trying to achieve. So at a high level, the broad challenge that we are trying to solve here is, how can we design a tool that enables in-depth understanding of communication traffic on the interconnect through tight integration with the MPI runtime? So this is a quick overview of the MPI+CUDA project, of which INAM is a part. So we've been running for almost 20 years right now, and we power many of the top 500 systems out there. Now, this is an overview of OSU INAM and the kind of features that it can offer. So currently, we have support for multiple job schedulers like PBS and Slurm. It has the ability to gather and display Lustre I for MPI jobs. And so several times people are kind of hesitant to deploy new profiling tools on a cluster. They would like to first understand the impact it has, how it works in a sandbox kind of an environment. So the latest release, we have an option to enable INAM to be run in an emulation mode for different kind of job size. So for instance, if you have a cluster the size of Frontier, which is 8,000 nodes, you can try to run the entire thing in a sandbox kind of an environment to see how various components of INAM is able to scale up to meet the requirements of such a large cluster. So for instance, if this cluster is running in a fully loaded mode with thousands of jobs, what is the load of MPI level data collection? Can the database handle it? What size of like a database do I need to have to manage all of these things? Is the end UI able to handle it? So all these kind of questions can be answered by running INAM in such an emulation mode without actually affecting your larger scale cluster. So again, we have support to collect and visualize MPI data based on the MPI tools information interface. We are compatible for different versions of MOFED, and we have also the ability to add user-defined labels for particular switches. So if you look at a reasonably large cluster, you could have like dozens or maybe hundreds of switches. So how do you like uniquely track this one instead of having like really long names that the vendors probably gave them? So can we have understandable names like leaf switch 1 or leaf switch 2, spine switch 1, rack 1, leaf switch, things like that. So we have that flexibility to give user-defined labels. And one of the things that system administrators mostly want is, hey, I don't want to keep looking at this screen every 24 hours. I would like a notification to be popped up when a particular event of interest occurs. So for instance, if there are error counters on the network, I would like to be notified. So INAM has the feature to generate notification emails where the users can say that, hey, if on this switch port or if in the entire network, the link utilization exceeds on any given link, if the link utilization exceeds 90%, let me know. So these kind of notifications can be automatically generated by INAM and sent to system administrators. So these are at a high level some of the features that INAM has. So again, this is a framework showing the design of INAM. So it has multiple components. So you have like a daemon, which is responsible for collecting information from the InfiniBand fabric, the MPI job, as well as the job scheduler. And all of these details are kind of fed into a MySQL-based database. And there is a web-based front end which pulls data from the MySQL database and displays it to system administrators, MPI developers, application scientists, and whatever. And of course, this web-based front end has support for authentication and validation, things like that. So we have enhanced the performance MPIT interface to collect different kind of metrics from the MPI job. So one of the guiding principles behind our design was that we did not want to have a daemon running on each compute node. So if you look at a lot of other profiling tools out there, what they would have is a individual daemon running on the compute node, which gathers the data and then sends it out to like a remote database or a remote process to get aggregated and then displayed. Now, one of the problems with this approach is that this particular daemon can cause jitter or like unexpected performance variations for applications running on that particular compute node. Now, with INAM, what we have done is, if there is no job running there, then we don't really care about it. If there is an MPI job running there, then the MPI library, like an instrumented MPI library, will send out the information to you at the appropriate times and at the appropriate granularity in which the user requested the data to be sent. So this gives a lot of performance optimization potential, and it, as you'll show in the upcoming slides, it has very limited impact because of this kind of a data collection method. We have very little impact if your application is running in an environment where it is supporting OSU INAM versus it is running on a MPI library without any support for OSU INAM. So as you can see, with NAS parallel benchmarks at 512 processes, there is little to no impact of using OSU INAM for real live applications. So this is one major thing. So using OSU INAM, you can have live introspection of processes running in a production environment without having to say, oh no, this was a debugging run, this was a profiling run, I can't use this data for any performance use cases. So this kind of alleviates that particular issue that users typically face with any debugging tool. So are there any questions so far? Okay. If not, we can move forward. And again, guys, I know you may be in all sorts of time zones, but I would like this to be a dialogue rather than a monologue. I can keep talking about this forever, but unless you guys are also interactive and ask questions, if you have any, that would make the session much more interesting and interactive. So going forward, I'll just highlight some usage scenarios and some of the features that INAM has. So INAM supports almost all the switch counters that the InfiniBand spec offers. So this is a list of the switch counters that INAM currently supports, and this is like a laundry list. I'm not going to read the entire thing. Please feel free to take a look at the slides for more details. So we support all sorts of performance counters from the network level as well as from the MPI level. And we also support several network error counters. These counters are particularly useful for HPC system administrators. So these are like the list. Some of the other few things that INAM offers you. I think there's a question here, so I can answer that before moving on. So the question is, can you explain again how INAM collects data without having a per node daemon? So INAM collects three to four different kinds of information. So one is, let's say, from the fabric itself, from the network, it collects a lot of InfiniBand port metrics. It then collects information from the job scheduler. So then it queries the job scheduler. For on-node information, we have an instrumented MPI library which keeps gathering information in the background at a very fine granularity with very low overhead. And the MPI library then periodically sends out the information for the entire node during idle phases to the INAM daemon. So this is basically how we are able to enable INAM to collect data without having a per node daemon. So at this point, okay, so there is a follow-up question to that. So the question is this MPI+2 specific? At this point, yes, it is MPI+2 specific, but we are trying to see if this can be made more generic through the MPI events interface. So what we want to do going forward, this is some of the future work that we want to do. So we want to create an MPI plugin, MPI events plugin, which different MPI libraries can load so that the data is collected at runtime and sent back to the INAM daemon. So once the MPI events interface is kind of more finalized and it is currently being worked out in the MPI working group, which is part of the MPI forum. So once this is like a bit more finalized and it is in a better shape, we would want to enable this for other MPI libraries as well. So I hope that answers your question. So going forward, there are like several use cases that INAM has. So this is one very interesting use case. So typically, what INAM allows you to do is it allows you to find out what is happening on any given link on the system. So, oh yeah, your typical InfiniBand network monitoring tool allows me to do that. Yes, that is true. But what INAM allows you to dig in, because of correlating information from the MPI library and the network, is that it can tell you, hey, on this particular link, you had job A and job B sending data, and process A of job A was sending data at the same time process B belonging to job B was also sending data. So this kind of information is possible because one, InfiniBand uses static routing, and of course with dynamic routing this will have to be updated. So still InfiniBand mostly uses static routing, and we are able to pre-calculate what route it was taken and what processes are taking those routes. So like if you open up INAM, which I'll show in a quick demo later on, it can tell you that on a given link, one process was sending out data, and these were the ranks in the which was sending that much data. So you can go to that level of information. You can also have like standard things like a communication grid for operations. So okay, there is another question in chat. Could you explain why INAM needs information from the scheduler? What sort of information do you get from the scheduler? So suppose you want to correlate what job this is, okay, and what nodes are part of this job. That information is available with the INAM daemon. So let me just quickly move on to a demo, which hopefully is up and working now. So what INAM has is, it has this concept of looking at live jobs which are currently running on the network. Okay, so let me try to move over from this presentation to like a demo. So are you guys able to see my screen of the INAM tool right now instead of the presentation? I assume yes. So this is how the INAM tool looks like. Now, we have multiple features and capabilities here. You can always look at the live network view. So this is like a local cluster that we have at OSU. Now, there could be different jobs running on this cluster. So how do you figure out what are the various job IDs? Because from an end user's perspective, I would know my job ID. So how would I figure that out? So if you go to the live jobs page, you will see that, hey, here is my job ID, and it has like 2 nodes. And this is the total amount of data that is being sent and received and things like that. Now, if I want to dig in further into this particular job, I would, let's say, open up that job level page. This will take me to a different page which shows me what all nodes are part of this job, what is happening for CPU utilization at the node level, what is my communication buffer utilization at the entire job level. So this is basically why we would need interaction with the job scheduler. So there's a follow-up question. Does INAM require privileged access? Is it supposed to be used by sysadmins only? No, using INAM does not require super user privileges. So as I mentioned, INAM has the ability to like provide authenticated access. So like you could have a root access and a regular user access. Like a super user would be, for instance, able to view all the jobs, but like a regular user would be only able to view the jobs that he or she launched. So we have that kind of let's say protection. So depending on the level of your user, you can either view information pertaining to all users or just like yourself. So yes, installing INAM will require super user privileges, basically because accessing InfiniBand's like a network requires super user privileges. But apart from that, for running INAM, for viewing all of this information, you would not need elevated permissions. So once you go into the job level page, you would see that INAM is able to list all the nodes which are part of this job. Now, if you want to, you can go down one further level to like a node level page to figure out what is happening on that particular node as far as CPU utilization, memory utilization, like communication characteristics and all of those things go. So now if you take a look at this particular node, we can also get the list of all the MPI primitives being used by this particular job. So all of this information is made possible because INAM is gathering data from 3 separate sources: the MPI library, the job scheduler, and the underlying communication fabric. So the MPI library is going to tell INAM that, hey, I am using all reduce. And if you click on that, it will actually tell you what sort of all reduce that you are using. So this tells you that, okay, I have 2 ranks using all reduce, and it is using a particular type of all reduce. So this is a PVAR, or a performance variable inside MAPICH2, which points to like a reduce scatter all reduce and a recursive doubling based all reduce. So if you look at it, we can also figure out the total amount of data being sent by this type of all reduce and the total amount of data being sent by this type of all reduce. This data is further classified into different buckets, and we can figure out how much time it took for data which falls into different buckets. So basically from this, we can say that for data which was like extremely large, which was greater than 1 megabyte, we spent about 171,000 microseconds. And if you hover over it, you can also see how many times it was called. So you can see that it was called like 473 times. So there is a lot of valuable information that INAM can provide you because it is correlating data from multiple locations and trying to present it in a unified way to the end user. Now, this is from an end user perspective. Suppose from a system administrator's perspective, if you go to the global network view level and you want to see slow internet connection. So, and if you want to see the same information about MPI primitives being used at the entire job level, the system administrator can still do that. So you also have other things like node level counter statistics and even like rank level or process level statistics to figure out what was happening. So this is like transmitted data, and INAM can collect data based on a particular user defined frequency. If the user tells INAM to collect data once every 5 seconds or 10 seconds or 30 seconds or a minute, INAM can collect data at that interval as shown here. And you can have like different kind of like metrics displayed here. So here we have like transmit data and receive data metrics. So that is at the node level. You can also have similar information at the rank level. So you have all of this flexibility with INAM. So if you go back to the live page, you would see that there are some jobs which are sending information to INAM, and some jobs which are not sending information to INAM, where we clearly say no data from MPI process for this job. So in this particular case, this job was being run by an MPI library which did not send information to INAM. So that is why we are not having information from within the node. But still, you can have like other type of information for this job regarding like what were the InfiniBand level port counters and what other nodes that are part of this job. So you can have other kind of information for like this particular job. Apart from this, like if you go to the main INAM page, you also have a lot of debugging information. So if you want to like create notifications, for instance, you can like create like different kind of notifications. So for instance, if you are a system administrator and if you want to say that, hey, I want to be notified if a particular, like for port counters, the link utilization percentage exceeds like perhaps, let's say 80%, okay? And this is a recurring event, and I want you to send this information to my email address and say that, let's say, some message, something like that. So you can create notifications like this, and INAM will send this notification to you like whenever this particular event has occurred. So this is like this is sample for the kind of notification that was given. So there are different levels of notification that you can have, either at the cluster level or a job level, for InfiniBand port counters or MPI process counters. So there are all different kind of notifications that can be generated. So going back to the live network view, so there is this link here for MPI as most used primitives. Oh, well, maybe I can show that later when the network does come back up. So yeah, so this is like the live network view. So you can try to get different kind of information from this view as well. Now let me switch over back to the presentation. Any questions before we proceed further? Okay. If not, let's continue. So this is like probably one of the demos that you will see when Karen and Hichang are talking like later on in Mux. So this is the OSC's fabric with like 114 switches, and I think this number has increased since then. And this kind of shows the average amount of time that you take to gather the, like these metrics. So like all of this is information that I showed currently. So like this is basically your live jobs page. This is your like nodes level profiling page. And you can also see what is going on a particular switch or on a particular node in your let's say system. So if you look at the live page, the blue dots that you see here are your compute nodes, and the red dots that you see are switches. So if you want to figure out what's going on in a particular switch, you can open the switch level information and see what's going on a particular port on that switch. So as you can see, there are two different kind of ports on this switch. Some are uplinks, which are going to like switches, and some are downlinks, which are going to like compute nodes. So the INAM is able to tell you all of this information in a very crisp and concise fashion. So as I mentioned, you also have like live switch level views, and as I had shown you in the demo, we can also show the amount of time it took for each primitive and the list of most used primitives in the MPI job. If you have an IO intensive job which is using Lustre, you can also try to figure out how much data is going between the Lustre clients and the Lustre servers, and how loaded it is, what is the minimum bytes rate per operation, maximum bytes rate per operation, like all sorts of details can be provided. So currently we only have support for Lustre, but future releases may have support for other like high performance file systems like GPFS and things like that. So this is like another use case scenario where you can run, like for instance, deep learning applications together with MPI+2, and for instance, find out what is the impact of batch size on GPU communication. So like from this graph, what you can see is that if you run TensorFlow with one sort of batch size and a different sort of batch size, from the network, you can see how that reflects in the amount of data being transferred. So broadly, what you observe from here is that smaller batch sizes result in like lower link utilization and is less communication efficient. So we already know this, like people who run TensorFlow applications already know that like you need to have like a large batch size so that your communication is more efficient. But this can tell you the reason for that, because smaller batch sizes leads to lower utilization, which is less communication efficient. So this is at a high level what INAM can do. So this is some of the future work that we are trying to do. So one thing is to see if we can have profiling for your GPU based applications. So what we are trying to do here is, and this is a work that we have published in HIPC conference last year, HIPC conference. So here what we tried to do was we are trying to profile the GPU to GPU and GPU to CPU as well as GPU to remote GPU communication in INAM by using multiple profiler threads, which gathers information from different GPUs and NV links and try to display it in a unified fashion for end users. So this will be one of the features that will be coming up in our next release for OSU INAM. So finally, let me conclude with some brief statements about future work. So again, this is like the 6th release of INAM that we have made from the OSU side. So INAM has been downloaded several hundreds of times from the OSU side. So it provides like a lot of capabilities to analyze and correlate and get a holistic view of your entire network and your entire communication stack, all the way from the application to the MPI library to the communication and IO systems, and present it in a unified fashion through like a web-based user interface. As part of future work, we are adding support to profile and analyze GPU-based communication, as well as the capability to profile various deep learning frameworks. So more details about INAM and how it works in a large-scale HPC center like the Ohio Supercomputer Center will be presented by Karen and Hee-Chung in their talk on Wednesday from 2 to 2:30 p.m. Eastern. Thank you for your kind listening. So please let me know if you have any questions. If not, I think we can move on to the
no,
next.
Now we have now we have the break.
Break.
Yes. So I think there is no nothing on the QA. And
actually, there's one more question. I can quickly answer that.
Sure,
so the question is it straightforward to dump data from INAM to do post analysis? So all data in INAM is stored inside a MySQL database. So it's a standard SQL query to get whatever data that you want. So like we have some publications which very clearly show the data, the structure of the tables, what is the primary key, secondary key, so on and so forth. So dumping it is very, very straightforward to do post analysis. I hope that answers your question. Okay. I think that is the last question, Dr. Panda.
Okay. So
yeah.
Thank you. We'll take a break here for 30 minutes and we'll get back at 1 p.m. US Eastern. Okay. So we have exciting 3 other tutorials in the afternoon. We'll be starting with from Microsoft Azure, and then we'll have the BROADCOM, and then followed by an extended version of the MPI+2 tutorial. So those are the 3 talks waiting in the afternoon. Thank you, guys. Please take a break and let's join in 30 minutes.
Hi all, can you hear me all right?
Yes, I can hear you.
Awesome. So let me just set up the screen share and
Sure.
get started. Thanks, Hari. Yeah.
That was 614.
I can see you.
Okay, great. You can see the full screen, correct, Hari?
Yes, it's perfect.
Great, thanks.
Hi, Jathan. Is my audio working?
Hey, John. Yes, I can hear you well. Thank you.
All right, perfect.
Perfect. Yeah, thanks.
Hi, John and Jiten, can you hear me?
Hi, Dr. Manda.
Yes.
Yeah, we can hear you.
Okay, good. So I think that your slides are also coming out just in the presentation mode. You need to change.
Yes, sure. Yeah.
Okay. So might be we can go back to the break slide.
Oh, yeah.
Huh?
Sure.
And
Sure.
then,
Yeah, that sounds great. Let me stop sharing then.
yeah.